Welcome to the Complete Theory of Computation course. In this lecture, we will indicate part of the syllabus that we will study and work with during the course. An important aspect to keep in mind about this course is that it covers the entire theory of computation syllabus that is studied in the university degree in computer science and computer engineering. Therefore, regarding the course syllabus, we will begin by studying the language theory, so we will introduce the language theory. We will look at the concepts of alphabets and words, as well as operations between words. Also, inside this language theory plane, we will work with the concept of language, the clean star or the clean closure, as well as the definition of a morphism. In this first section of language theory, we will work with the fundamentals of computation. It's a very important section that will build up the pillars to understand the following sections. The next section that we will study and work on is the automata theory, that is, the study of abstract machines and automata, as well as the computational problems that can be solved using them. So we will look up the process of verification, non-deterministic finite automata, also the push-down automata, or the deterministic finite automata. In fact, in this course we will work with all of the types and kinds of automata that we have in automata theory, as well as solving many problems on this section as well as in the language theory section. This course has a lot of problems that are all solved. The next section is going to be about the non-contextual grammars, also called context-free grammars. We will study in detail the properties of this type of grammars and their use. So we will see the derivation tree, the ambiguity that may be produced in the production roles that we have in non-contextual grammars. This section is going to be very attached to the section of regular expressions that we will also study in this course. In fact, in this lecture we are only indicating some of the topics that we will study. This course is very broad. It is a complete course of theory of computation that covers all the concepts. So this section on non-contextual grammars is going to be very important in order to understand the regular expressions one. Another very important topic that we will cover in depth in this course is the Turing machines. We will study very broadly this topic, so we will define what a Turing machine is. In fact, we'll say that we can transform any Turing machine in any programming language. We will study its extensions and most of the theses that we have on Turing machines, namely the Church-Turing one. Besides, in this course, we will cover the section of decidability problems and reductions, in the sense that if I have a problem A and I know some properties of this problem, I can reduce this problem A to another problem B and prove that this problem B also verifies these same properties of the problem A, with PDF document files and all of the problems with their solutions, so that the student can download and see the solutions by him or herself. And as we said before, these are only some of the topics that we will cover. And as we are going to see, we will have many more topics. Therefore, whether you're a beginner or if you want to improve your knowledge and considerably increase your level, this is your course. This is the most complete theory of computation course on Udemy, as it covers all the content studied in the university degree in computer science and computer engineering. With this, we finish the lesson on the main topics that we will cover during the course. See you in the next lecture.